Is the jet stream becoming more unstable? Have you ever wondered how the jet stream affects our weather? The jet stream, especially the polar jet stream, is a fast-moving band of air that circles the Arctic. It plays a key role in shaping weather patterns across the Northern Hemisphere. Recent changes in the polar regions are raising questions about its stability. The Arctic is warming at a faster rate than other parts of the planet. This rapid warming reduces the temperature difference between the cold polar air and the warmer air in the mid-latitudes. This temperature gradient is essential for the jet stream's strength and speed. When this difference shrinks, the polar jet stream tends to slow down and weaken. A slower jet stream has less momentum to move steadily eastward. Instead, it becomes more prone to large north-south bends or waves, which are known as meanders. These meanders can become more pronounced and persistent, causing the jet stream to appear wavier and less stable. This waviness allows cold Arctic air to spill southward into mid-latitude regions. This can lead to extreme cold spells in areas that usually enjoy milder winters. Conversely, warm air can push northward into the Arctic, which accelerates ice melt and further warms the region. The result is a rise in extreme weather events such as cold snaps, heat waves, floods, and droughts in populated areas. Another factor to consider is the polar vortex. This is a circulation of cold air around the Arctic. When the polar vortex weakens or breaks apart, it disrupts the jet stream below. This disturbance contributes to the jet stream's waviness and instability. The jet stream can split into multiple branches or shift away from the pole, amplifying extreme weather patterns. Research, including laboratory experiments and observational data, confirms that as the Arctic warms, the jet stream's eastward movement slows down. Its structure becomes more complex, leading to more frequent extreme weather events. While some regions may experience milder temperature extremes, the overall frequency of extreme weather linked to jet stream instability is on the rise. From the perspective of the polar regions, these changes in the jet stream are a direct result of Arctic warming and sea ice loss. The altered jet stream not only impacts weather for beyond the Arctic but also feeds back to accelerate warming and ice melt in the polar environment itself. This creates a cycle where polar climate change drives jet stream instability, which in turn influences global weather patterns. In summary, the jet stream is becoming more unstable due to the rapid warming of the polar regions. This instability leads to slower, wavier jet stream patterns that result in more frequent and persistent extreme weather events, both in the Arctic and across mid-latitude areas.